Let's talk about application problems for rational. So there are two types of application problems. Hopefully you can recognize it. Every time you see the words working together, you know we have a work problem. So for the work problem, you set up, which is two things working together or two people working together. So you pretty much just find the rate of each and add them up because they're working together, so that we can add the rate together. Don't forget, the rate is not, don't get confused between the rate and the time. So for example, in this case, we have the older pump and the newer pump. So let's take a look at the rate of the older. It takes the older pump 12 hours to drain the pool by itself. So the rate would be 1/12. Now we don't know how long will it take the newer pump. So the rate of the newer we don't know. So we put 1/x. We don't know how long. Now the rate of the two working together we do know, which is 3 hours, which makes sense because that's the smallest number. It should be that way because they're working together. So to set up this problem, I just have to add them up. So the rate of the older add up with the rate of the newer, we should get the rate together. And then once again, solving this problem, I'm just gonna get the LCD, which is 36x. I'm sorry, it's 12x. All right, so we have x plus 12 equals to 4x. So 12 is going to be 3x. Divide by 3, divide by 3. So x is 4. Okay, so 4 hours. That's going to be the number of hours it takes for the newer pump to drain the pool on its own. 4 hours. Moving on to number 29. What we have right here is a motion problem. Every time you have motion problem, you know that we have to come up with D equals to RT. Now we have two scenarios. We have with the current and we have against the current. So our job is to write DRT for each scenario. So I have with the current and I have against the current. And we have R, we have T, and we have D. Now, we know the rate of the current is 4, but we don't know the rate of the team. So let's cause X. That's going to be the rate of the team. Now for the rate when the team going with the current, so we just add 4. Going against the current, we subtract 4. We have the distance is 90 miles. We have the distance here is 10 miles. The problem is we don't have the time, but you can solve it because T is just going to be D over R. So I'm going to put D over R, D over R. Now what I have right here is the rowing team rowed 90 miles while going with the current in the same amount of time as it took to row 10 miles going against the current. So to set up the equation, I simply put the time and set them equal to each other. Same amount of time. Then you can see that we can just simply cross multiply. Okay, so if I move, I subtract 10x, I get 80x here. And I get 40, I get 400 here. And then when you divide, I'm gonna end up with 5, which is 5 miles per hour.